Okay, so we have a number of people in here. Today's topic is GetVPN. We're going to have a Q&A session at the end. I try to look at the questions throughout the webinar, just in case there's something pertinent that can't wait till the Q&A. If I don't see it, then we'll get to it then. Okay, so again, this is GetVPN, or Group Encrypted Transport. This is going to be tailored towards experienced network engineers. Obviously, if you just got your CCNA, maybe a little over your head. And for people prepping for the CCIE Security Lab, this very much follows the type of GetVPN that you'll see on the lab. So here's what we're going to cover today. An intro to GetVPN, just basically what it is and what it's for, and then some configuration examples, including the key server itself and the key members that are actually going to be doing the encryption. At the end, I'll be doing a lab demo, and again, fairly simple and tailored towards what you'll see on the CCIE lab, at least based on what I've seen of the CCIE lab. And then at the end, we'll have a Q&A session where I will attempt to answer any questions that you might have, or at least get you pointed in the right direction. Okay, so let's get started here. GetVPN is a Cisco technology. They designed it using IPsec technology as the base. So there's not going to be too many new and hard-to-grasp concepts. If you've been a network engineer or a security guy for a while, I'm sure you're familiar with IPsec tunnels, encryption protocols, and hashing, and all of that. None of that changes. It's still used. What Get does is it centralizes the key management, and that means by the key management, not authentication keys, but encryption keys, so that there's no need for a tunnel to be negotiated, meaning IPsec essays. That doesn't have to be negotiated between each individual router in the conversation. Because of that, with everybody having the same keys, you've got full mesh encryption. Anybody can talk to anybody as long as they fall within the configured policy, and we'll see how to configure the policy later on. In addition to that full mesh encryption and centralized key management, Cisco has a technology they call IP header preservation that is going to, like the name suggests, preserve the original IP header. So that includes the type of service field for your QoS, and also allows for multicast to be encrypted without the need for things like GRE that add on additional overhead, additional header to your traffic. Okay, so where will you use GetVPN? Cisco was really thinking here. It's best to use, like it says here, to encrypt traffic across networks that need full mesh connectivity and encryption. So a great example of that is you are going to be transmitting data across your corporate network, probably sensitive data, credit card information, social security numbers, medical records, etc., across a provider's network. Now, in the olden days, we generally trusted our providers, whether they were offering, frame relay or ATM, or even MPLS in the last few years. However, we shouldn't necessarily trust them. There's nothing to say that there's not a low or a mid-level or even a high-level technician with a lack of character that might want to steal some of that data. So the provider, generally they're free to sniff data as it goes across their network. So the idea here is to encrypt things as they go across maybe a provider network. MPLS being the most common that are in use these days. So previously, we may have done that using something like DMVPN or just regular old IPsec tunnels. And there's nothing wrong with doing it that way, but the configuration can get complex, especially if you have a lot of sites that are going across the MPLS network, or if you need to do a hub and spoke type of thing with the DMVPN. And all those individual tunnels getting built up and torn down and so on. And of course with DMVPN there's the additional overhead added by using GRE through IPsec. Okay, so yeah, that's where you'll use it, generally across a provider network. Here are the components of Get. You have a key server, and again, the key server is for centrally managing encryption keys, as well as IPsec essays. So the idea here is all of the group members are going to register to the key server, do their authentication with the key server, not with each other, get their encryption keys pushed down by the key server and not negotiated, between each peer. Once they have those encryption keys, they're free to encrypt and decrypt traffic among any other group members that are using those same keys, meaning anybody who's registered to that same key server. So again, centralization of your encryption keys and authentication. Okay, the group members are the other component. The group members are simply a router that's going to be taking part in this Get configuration. And again, all they're doing is using a simplified process where they register to the key server, get their encryption keys and their IPsec SA pushed down to them, and that includes, again, encryption keys and your crypto ACL to let you know what you're going to be encrypting. Once you have that, then you're free to encrypt and decrypt across your network. You guys, pardon my sniffling. I don't have a cold. Just have allergies. Middle of summer up here. Okay, so the new technologies, because again we're all familiar with IPsec encryption protocols and hashing and pre-shared keys versus certificate authentication, all that jazz. The new stuff is GDOI, or Group Domain of Interpretation. All this is a modified version of the ISACAMP protocol that allows the group members to authenticate to the key server and register with the key server and get their policy pushed down. So GDOI, that is just a modified version of ISACAMP. IPsec tunnel mode with header preservation. I mentioned that earlier. We are still using IPsec protocols, and that means ESP. But the headers get preserved, and this is kind of Cisco's secret sauce. They don't release a ton of information about it, but they do preserve the original header to use it with the encrypted traffic. And again, that's going to preserve things like the type of service field in your IP header, so you can have your QoS markings survive. And multicast will still work. Okay, Get will also do periodic rekeys, and that means it's not just going to have a client register with the key server and then use the same encryption key until the end of time. That would introduce some vulnerabilities, possible theoretical vulnerabilities for that key getting broken. So there's periodic rekeys that gets pushed out to the client, either unicast, which most people that I've seen do this in the real world use, or multicast. It's possible to multicast rekey to save a little bit of resources. Also, you wouldn't want your key server to go down and your Get network not work. So there are what are called co-op key servers. That's redundancy. It means that multiple key servers can share the load for registration and for failover in case one of the key servers reboots or the router goes out or whatever. Okay, so as mentioned, GDOI is a modified version of ISACAMP. Instead of using UDP 500 like you would use with ISACAMP, it uses UDP port 848. So if you have firewalls in place, you're going to need to allow that traffic, UDP port 848. And if you run into this, like say on a CCIE lab, assuming that you have logging turned on your firewalls, which you should, even if you forget this, you'll see the UDP port 848 being denied. That should instantly trip in your head. Oh, I know what's wrong. Better allow that. And that holds true for introduced errors like VACLs or ACLs that have been dropped on routers. You need to allow that UDP port 848. Okay. Other than that, initially connecting up is going to look like ISACAMP, and that means you'll set up an ISACAMP policy that'll include encryption, hashing, your lifetime, as well as whether you're using pre-shared keys or certificates for authentication. Once you authenticate to the key server, you're going to get two sets of keys pushed down to you, and they're called KEK and TEK. KEK is the key encryption key that's only going to be used to encrypt the re-keys that come from the key server. Obviously, those are encrypted so that somebody listening in on the conversation can't just get the encryption key. The TEK, or traffic encryption key, is what actually gets used to encrypt traffic across the GET network. So if you want to, you can think of the key encryption key, or KEK, as your IKE Phase 1 policy, and the TEK for your IKE Phase 2 or IPsec policy. Okay, so we ran through fairly quickly there, the technology, generally how it works. So now let's take a look at the configs and how this gets configured. So it's really a two-part configuration. The first part is the key server. You have to set that up, and that's going to include the GDOI settings, which are just an ISACAMP policy, your IPsec settings, which is going to include the crypto ACL, your transform set, an IPsec profile, and then the GET specific setup itself, what IP address the clients are going to register to, what type of rekeying you're going to use, and so on. Very important here, this is something that everybody thinks is a little bit goofy when they hear it. The key server does not participate in encryption. It doesn't take part in the GET network. Yes, that's pretty strange. I'm not sure why Cisco designed it that way, but your key server is not going to be doing encryption and decryption. So what that means is, if you are doing this in the real world, you're going to have a router that just sits there, doesn't take part in the network, has to be reachable by all the group members, and is just going to handle being a key server. Like I said, a little bit goofy. Kind of out of the scope of this webinar, but people have done some tricky stuff to try to get the key server to take part in encryption. What they'll do is they'll use a different GET configuration just for the key server encryption part of it, and then another separate one for the actual encryption across the GET network. Like I said, you can. It's out of the scope of this webinar. We're not going to get deep into that, but you can Google around on the internet and see some of those design guides and people that have done it. Okay, so again, it's a two-part config. First, you configure the key server, then you configure the group members so that they can register with the key server, authenticate, get their policy, and so on. So for the key server configuration, it uses ISACAMP, GDOI does. So you have to configure an ISACAMP policy exactly the same as you would for a regular, plain Jane IPsec tunnel. Authentication, as stated here, you can either do it with pre-shared keys or by using a digital signature, RSA SIG. We're going to show the pre-shared version in the example here as well as in the demo, just for simplicity's sake. If you want to use digital certificates to authenticate, it's up to you how to do that. It's easy enough to run an iOS CA server on the same box as the key server. Or if you already have a CA somewhere else on your network, you can use that to hand out the certificates. Just realize that if you're going to do that, that has to be reachable by all the group members, or you have to do it manually. Okay, so the ISACAMP SA isn't really being used other than initial registration for the group members. So it's a general best practice to set a really short lifetime for your ISACAMP SA. That's going to, especially if you have hundreds of group members registering to this key server, it's just going to free up resources on the router. So here's an example. Again, this is going to look very familiar if you've ever configured an IPsec tunnel, which you probably have if you're watching this. Like I said, the only thing to note here, other than a standard ISACAMP policy, is that we've set the lifetime here to 300 seconds or 5 minutes, again, because that ISA really isn't being used, and we want to free up the resources. Okay, so having done that, we got to configure a transform set and an IPsec profile that's going to reference that transform set. That's, again, fairly basic. If you've done DMVPN or anything else that uses IPsec profiles where you're putting something on a virtual interface, remember here that what you set is going to be used to encrypt all traffic on your GET network. And I mention that because if you read the Cisco white paper on this, it tells you clearly that these IPsec SAs have a theoretical lifetime after which they might be compromised. If you are using a large number of hosts on this GET network, the encryption key, the lifetime gets much smaller the more hosts you have, and of course the more traffic that's being encrypted using those keys. So TripleDes, because of the way it's built, has a much lower lifetime. AES 128 has a much higher lifetime, theoretical lifetime again. So the take-home message here is if you're using GET in the real world, use AES 128 or stronger encryption. Again, the white paper that Cisco has, if you Google for it, gives you an example of X number of hosts encrypting X amount of data and how long the keys will last. And I don't recall the exact numbers, but I think they say something like, it's 3 hours or 2 hours or something like that for TripleDes, and it's hundreds of years for AES. So use AES if you're doing this in the real world. Okay, again, this configuration isn't going to look too terribly difficult if you've ever done DMVPN or something like that. We're going to set up a transform set that I called GET. It's using AES and SHA for hashing. Then I'm going to create an IPsec profile, also called GET. I like to name things that way so I can keep the configuration clear in my head. Everybody's got their own method for doing this. Okay, but under this IPsec profile, set the transform set to GET. Again, pretty basic stuff. Nothing tremendously difficult or out of the ordinary there. Okay, so with the standard IPsec part of it set up, here's the thing that more people aren't as familiar with, the key server configuration. What we do here is set up a GDOI group at an identity number. Both of those are going to be referenced later by the client, the group member. We're going to set the server up to local, and that's how the router knows that it's a key server. Because again, the GDOI group, when you set that up on the group member, the configuration is similar, but instead of saying server local, you say server and then the IP address of the remote key server. So server local says I am a key server. We'll then set up the rekey mode, and again, these periodic rekeys are going to happen as a part of GET, and they're either going to be done unicast, which is again what most people use, or multicast. A note here is that if you're going to be using unicast rekey, which you probably are, rekey authentication has to be set, and that is actually done with RSA keys that you have to generate. Not sure if I have that on the configuration, but it's certainly in the demo that we're going to do, so we'll see that later. The multicast rekey doesn't require that. So you also set the IP address that you're going to use for the server here. And again, that's because you could be doing this on any number of interfaces. You might do it on a loopback interface, might be on a serial interface or fast Ethernet interfaces, whatever. You have to set up the IP address that the clients are going to use to register with you. So here we go with the config. Again, we set up the GDOI group, which is called GET. Again, this is my naming convention. Identity number 1. Server local. Again, that says I am the key server. I'm using rekey transport unicast, so I also have to use rekey authentication using my public key, RSA, and the name of my public key. So again, you have to pre-generate this this set of keys just with the crypto key generate RSA label r1.test.com mod 1024. Just do that command before you configure your key server, and then reference whatever you labeled the keys here in this line. Let me get rid of this so it doesn't confuse. Okay, then we will say SA IPsec1. This is going into the sub-configuration mode where we'll set up our policy. So we'll be using the IPsec profile called GET. That's what we created earlier. And we're going to match IP or match address IPv4 101. Doesn't take Sherlock Holmes to figure out that that's an extended ACL. Notice that we didn't show creating an ACL. You don't have to. You can create that ACL later. Again, just make sure it has the right, the matching ACL number. Address IPv4 and then the IP address of the server. So again, set this up knowing that this is going to be the IP address that the group members will register to. That means that that IP address has to exist on the server, on this router, and it has to be reachable by all your clients. So that's an important note. Don't make it a loopback that you're not advertising into a routing protocol or that's not reachable by the rest of the group members for whatever reason. If it's not reachable, obviously you won't be able to, the clients won't be able to reach it and register. Okay, so the crypto ACL, you can create that now after you exit out of the GET configuration. Anything in this crypto ACL that has a permit statement is going to be encrypted. Anything that has a deny, including the implicit deny, is not going to be encrypted. So no new concepts there. That works exactly the same as it would for a regular site-to-site IPsec tunnel. Should be noted here that even though it works the same as a site-to-site tunnel, what you actually put in the ACL is usually going to be different. Generally, since GetVPN is used as a full mesh encryption, usually you'll be encrypting from a private network to a private network, and usually they'll be the same thing. So if you're RFC 1918 address space, you've chosen 192.168, 3, 4, 5, 6, 7, etc. For all of your sites. You could simply do a crypto ACL like we're going to do in the demo later that encrypts from 192.168.00/16 to 192.168.00/16. Again, you'll encrypt anything that's going on between that between those networks. It should also be noted here that you might want to exclude some traffic from that from that ACL. Routing protocol traffic, if that's what's setting up the connectivity between clients. Again, you might want to exclude that stuff so it doesn't get encrypted. You'll certainly want to exclude the traffic for UDP 848 between the group members and the key server. Otherwise, it will attempt to encrypt that as well, and your rekeys won't work, and so on. Again, I'll show you that in the demo when we do that later. Okay, so what I just showed you was a basic configuration for a key server. Some of the other things you can do with GetVPN that I didn't show, co-op key server configuration, where you set up failover key servers. I believe you can do up to 8 key servers in one Get group. And again, you can share the load and registration, and you can have them fail over. Multicast rekey, didn't show that either. The way that works is you set up an access list that's going to reference the address that you want to multicast to. And again, that's just for efficiency's sake. If you have a large GetVPN install, you may not want to do 1,000 unicast connections every time you do a rekey, although it may not even cause a problem. But yes, you can do it with multicast. There's config examples all over the internet for it. RSA SIG authentication for your initial registration with the key server. Again, that works the same as it does for a regular IPsec tunnel. So, the gotta do's there. You need NTP, so the time is synced between the clients and the CA and the key server. Everybody's got to set up a trust point and enroll with the CA so you can get a certificate. After that, of course, the authentication won't use pre-shared keys; it'll just use certificates. Shows here more inclusive encryption, like an ACL with encrypt any. Again, we'll see that in the demo. And exclusion of routing protocols. I talked about that as well. All right, now let's look at the group member configuration. This is super simple, with the idea being you make it easy. Everybody has just about the same configuration, so with some minor changes or maybe even no changes depending on how you standardized your install, you can just drop this configuration on 100 routers at a time or whatever, and have everybody connect up to the key server and get registered and start encrypting. So you can see here the ISACAMP policy is the same as the key servers, obviously, including the short lifetime there. Nothing new or fancy there. It's the same as a regular old IPsec configuration, as well as the pre-shared key. I should note here that you could do the specific address here. I just use all zeros because I'm lazy. But yeah, you can put the key server's actual address in there. Just be careful if you have co-op key servers and you want to put in the specific key. You'll need the address for all of your failover key servers in there. Okay, here's the actual client configuration. Similar to the server, you're going to do a group. I called mine get, identity number 1, set up my server address. Instead of being local, I point at the key server address that I configured earlier. So there's my GDOI setup. Then I create a crypto map with a type of GDOI, and I set my group as get. That's this group right here. You know, once I have that, like a regular crypto map, I've got to apply it to an interface. So that's what we do in the next section here. Go to whatever interface you're going to have reachability with the key server with, and simply apply it just like you would any other crypto map get in this case. As soon as you type that in and hit enter, it will attempt to register with the key server. So make sure you have all your stuff in place, and that means IP reachability, any ACLs that might be needed to be tweaked through a firewall, as well as all your proper ISACAMP settings. Make sure all that stuff is in place, because again, as soon as you put this on and type enter, it'll try to connect to the key server and register. Assuming that you've configured everything correctly, all of your ISACAMP policy matches up, your authentication is good, RSA SIGs are good if you're using those, you're going to get a pop-up message on the console that says registration for whatever key server complete, and at that point you can check your GDOI settings and try to maybe ping back and forth to see if things get encrypted. Okay, so real quick, I'm going to check the questions, make sure. Somebody says here, is group 2 for Diffie-Hellman mandatory? No, it's not. That's just a standard setting for me. Whenever I do ISACAMP policies, I always try to use at least group 2. Okay, so here's the lab we're going to be using. I tried to make this as realistic as possible. So I've set up a tiny little MPLS network in the center here. I've got R2 is going to be the key server. We've got, just like you would in a real MPLS network, you have BGP peering to the PE router. We have all of our networks here advertised into BGP. So all of our routers here, R2, R3, R4, and R5, all know about all of these individual /24 networks. Of course, with our GET, the idea here is going to be to encrypt traffic that's going from any 192.168 network going to any 192.168 network. So the tunnels are going to be encrypting, well, they're not really tunnels, but they're going to be encrypting any traffic from a 192.168 network to a 192.168 network, again, without having to do any kind of per tunnel negotiation. So that's the idea here. I'll show you the configuration, and then once it comes up, I'll show you the show commands. So let me get secure CRT up here. I see that I have talked too long and lost all my connection, so I gotta re-authenticate and clear some console ports here. So bear with me. Again, if I wasn't too lazy, I would set a keep alive on this or something so that I wouldn't lose connectivity in the middle of a demo, but that's all right. I like to say that this is a demonstration of troubleshooting skills, but I'm really not troubleshooting much here. Okay, so now we're connected. R2 is our key server. Again, R3, 4, and 5 are the hosts that are going to take part in Get. So let's do a little discovery here. Do a show IP interface brief. This is the interface that's connected to the MPLS network. This is a loopback interface that's simulating, the corporate part of my network, the traffic that I want to encrypt. If I do a show IP route, again, BGP, I have a BGP peering to the provider router, and I've learned about all of the other sites, 192.168 networks. So those are there, and we have reachability at this point. I'll prove that real quick. 4.4 from loopback 0, which is my my corporate network. So right now, because of just regular old BGP and MPLS like you would have with a provider, I have reachability, but this traffic is not being encrypted. So again, if I'm a healthcare provider and I'm sending medical records across that network, I may have some problems with HIPAA compliance. So now I'm going to roll out Get so that information is encrypted as it goes across the network. So I've pre-done this so we don't sit here for an hour watching me accidentally troubleshoot something if I fat finger a config. Here's my IP domain name, CCBOOTCAMP.com, and then I'm going to generate crypto keys. Remember again that on your key server, if you're using Unicast rekey, you're going to be doing that rekey authentication, so you need to pre-generate these keys. I didn't stick a label on them because they're going to come up as the host name plus ccbootcamp.com, which is my domain name. I'm just going to drop this on the router, and it's going to generate my RSA keys for me. Okay, so next part of the config. Again, this is very similar to standard old ISACAMP policy. I'm using triple DES and SHA. Why not AES? I could use AES and probably would in the real world. That's the first thing I typed. Again, I'm using group 2. That's not a requirement. If you don't type in group 2, it's going to use the default, which for routers is Diffie-Hellman group 1. All right, so I've got my ISACAMP policy in there, which again is going to be used for GDOI. I'm going to create a transform set, which is going to use AES and SHA. If you're going to be more secure, this is the place to do it. Again, this is what's actually going to be used for encrypting traffic across the network, not just the encrypting the key encryption part of it, which is this. So I'm going to create a transform set, and then I'm going to create an IPsec profile that's going to reference that transform set. So I'll drop that in. So far, so good. And like I said, up until this point, we haven't done anything that's any different from a regular IPsec configuration. Now here's our server. Crypto GDOI group get using identity number 1. Yes, this name and number have to match on the clients. Server local, which once again means this will be the key server. I'm going to do my rekey authentication. If you forget to type this, don't worry. When you do your show run, it's going to clearly state in the config that your rekey configuration is not complete because authentication is not configured. Rekey transport unicast. I've set the rekey lifetime here to 300 seconds. That's as low as it'll go. That's 5 minutes, and I've done that so that we can actually see a rekey go on. After we do this configuration, I'm going to try to drone on for at least 5 minutes. with the show commands and so on, so that we can see a rekey actually occur. Okay, my SA IPsec1, again, this is going to drop me into a sub-configuration mode where I will set the IPsec profile that I'm going to use and set the access list that I'll use. Finally, I'll set up the server's address, which is going to be, again, a reachable IP address, and then configure the access list. So let me paste this in, and then we'll talk about the access list. There it is. As soon as I did this, it turned on GDOI and transitioned the group get to unicast rekey. Multicast, by the way, is the default. So if you forget to type rekey transport unicast, you may have some issues because you haven't set up the rest of the multicast config. Okay, so let's take a look at our ACL here. What I've done here is put a deny statement denying UDP from any to host 192.168.2.2. I originally put that in there because I was going to have people register with the instead of this 10 address, the 192.168.2.2 address. I actually don't need this line in here. In a different situation, you might, and that's why I left it up here, even though I'm not going to paste it in when I actually do the config. Again, usually when you do get, you're going to do something like this. We're going to permit IP from 192.168.0.0 to 192.168.0.0. If the key server is on this network, then you need to exclude the key server, at least the UDP 848 traffic, the GDOI traffic. You need to exclude that from your ACL. Again, I don't have that problem. We're not encrypting any of the MPLS provider traffic. That's where our BGP is set up and so on. We don't want to screw up routing on this network. So I'm just going to encrypt the corporate network traffic, which is what we need to do anyway. Okay, so I've got that in there. That's my my key server configuration. Again, there's other stuff you can do here, like co-op key servers and multicast rekey and so on. We don't really have the time to show all of that in a 1-hour webinar. You know, I'll give you a link at the end of the webinar that you can go to a discussion forum, or you know, I can give you that info. Or my email address or whatever. Cisco has a white paper on it as well. Okay, so the clients themselves, again, ISACAMP policy, pre-shared key, if you're using it, has to match. Here's the GDOI part of it. We're going to set up a group called get with an identity number of 1. Again, that has to match what's on the server. Oh, look, I did set up the server address for 192.168.2.2. That's going to be an issue up here. So let me change this to 10.1.2.2. Then create a crypto map that references this group and apply the crypto map to an interface. So I'm just going to drop this whole config on here onto router 3. If all goes well here, wow, look at this. Looks like I didn't hit save before I finished my config. Let me repaste that part of it. Okay, so as soon as I put the right name in there and apply the crypto map, it started the registration to the key server 10.1.2.2, and I got a registration to key server 10.1.2.2 complete. Now I'm up and running there. All right, so let me real quick drop this onto the other routers. Notice all I did was change the interface here. Depending on how your network is actually set up, you might not even have to change the interface, and you could just take this exact same config and drop it on, 100 routers. Script that with, something like SolarWinds. Do router 5 as well. Okay, so everybody's registered, or so my console messages have told me. So now let's look at the show commands so we can see that this thing is working. Back to the key server. I'm going to do a show crypto GDOI. This is your bread and butter command for letting you know if it worked. You can see here that my group name is get, identity number is 1. We know that. It's using unicast rekey because I set it up to do that. This key server is the active one because we don't have any others. If you had a co-op key server, it might have another, if we were a secondary server, it might have another IP address here. Rekey lifetime is 300 seconds. We got 216 seconds to go before our next rekey. Again, I'll try to talk long enough that we get to see a rekey. I've got 3 group members. Those are my my 3 group members that have registered, routers 3, 4, and 5. IPsec SA1, I only set up 1. Rekey lifetime, 3,600 seconds. The profile name is get, and so on and so forth. It's using access list 150. All right, so everything looks right here. I have my 3 group members, and again, that's important. It's also important to note on the actual CCIE lab, if you see something that says, show your output should look like this, and they show you a printout of this show crypto GDOI. Yeah, you just want to make everything match as it does there. So if you got 3 people joining, it should say 3. Again, just make it match. Okay, so how do we know this is actually working? We can do our show crypto GDOI on the clients. It looks different on the clients, of course. They're not a server. Shows that we have registered using group name get, identity number 1. We registered to 10.1.2.2. It says here group server list. If we were using co-op key servers, there would be more than 1 IP address in here. Since we only have 1 key server, it only lists 1. All right, it shows us the ACL we downloaded that is permitting IP from 192.168.0.0 going to 192.168.0.0. Again, that ACL encompasses our entire corporate network. Got the key encryption policy. Remember that the lifetime is set up for 300 seconds. And again, I just did that for demonstration purposes so we can see a rekey. It's using triple DES and SHA for hashing. So that's the key encryption key policy. Again, the KEK, that's the GDOI policy. We also have the traffic encryption policy. This is our actual IPsec SA, what's going to be used to encrypt the traffic across the network. Just like a regular IPsec tunnel, you can do a show crypto IPsec SA, and it's going to show you the all important packets encapsulated and decapsulated, encrypted and decrypted. This is how you know it's working. So let's do this. Remember that, oh, look what just popped up. I received a rekey for group get from 10.1.2.2 to me, because it's unicast rekey. It's got a source and destination IP address with sequence number 1. So I got my very first rekey there. So now we know not just that registration worked, but that that rekeys are working as well. All right, so I'm going to ping 192.168. Let's say 4.4. That's router 4's corporate network. Hey, it pings, great. We don't know that anything's been encrypted or not, but at least we have reachability. We didn't break anything. If I go back and do this show crypto IPsec SA now, looks like I may have done something wrong here. Nothing encapsulated or decapsulated. Here's what I did. I just did a ping without putting a source in there, so it's actually worked as advertised here. I did a ping from my interface IP, which is 10 dot something, going to 192.168. That does not match the crypto ACL. Good unintended demo there. Okay, if I actually type the right thing, and this is, I'm pinging the corporate network from loopback 0, which is my 192.168 interface. Still pings. If I go back and do the show crypto IPsec SA, now you can see that I've got packets encapsulated and decapsulated, encrypted and decrypted. That means that the encryption has happened, and now I can go back and tell my boss that the HIPAA compliance guys or the PCI compliance guys can check that box at least, because the sensitive data is protected. Okay, so that's how we know it works. Again, the show commands are for the actual IPsec traffic are the same as for a regular IPsec tunnel. Just notice that the identities here, local identity is 192.168.0.0/16. Remote identity is the same thing, 192.168.0.0/16. So that's good news. It means we're encrypting from that whole network to that whole network without needing to do individual tunnels between all of our different sites. The other show command to remember again is show crypto GDOI, and that's just going to show you the registration and the get specific stuff. Mainly what server are you registering to, and that you got the correct ACL from the key server. Okay, so that's the end of the demo. Let's do before we go on here to the sales part of this. I'm going to look at the questions here. It says here, how do you set a primary and backup key server on the group member? It's actually really simple, and I'm glad somebody asked that question. When you do your config, and I guess I can show it on the real thing here. If I do a show run section GDOI, hopefully it'll take me to the right place. If I go to my crypto DDoI group get and do server address, all I have to do here is type in a different server address, and it'll basically go down the list in order. So if I wanted to add another one, 10.1.2.3, another key server, IPv4, it's as simple as that. And again, it goes in order down the list. So let me run that show command again. On the group member, it would first try to register with this. If the registration didn't work, it would try to register with this IP address and so on. So you could change up that order and have half your clients try to register to one as their primary, and half your clients try to register to the other as the primary, and then those two key servers could back each other up. So that's how you do that on the client. Of course, you have to do the co-op setup on your key servers, and again, we didn't show that. Okay, another question here says, GetVPN can be dynamic, as in DMVPN. It doesn't. Again, it doesn't build tunnels, so it's not dynamic in the sense that it'll build a separate tunnel. it's dynamic. It's static dynamic. Everybody has the same encryption keys, so you can feel free to send to anybody that matches the crypto ACL, and you'll just encrypt that traffic using the push down key, and then it'll go out to again any other group member. So it's not really dynamic in that it's building separate tunnels. It's just encrypting the traffic and shipping it off, knowing that the other side has also registered and has those same encryption keys. Let me know if that answers the question. You can also run GetVPN within DMVPN. There's an example of that if you have if you're prepping for your CCIE lab. If you have the Yusuf's sample labs, his book that has the two labs. There's an example of Get with DMVPN in there. Let me scroll down a little bit more here. It says, what is the group server list in show crypto GDOI? I mentioned that earlier. I don't know if that question got asked before or after, but again, if on my key server, if I do co-op key servers, actual backup key servers, there'll be a list of all of the available servers in there. See that I've, because I typed the other one in my group member setup, I now have another server listed there, even though that server doesn't really exist. That's the secondary server that I put in. So this is my list, and again, it shows it in order. So this guy will first try to register to 10.1.2.2, then he'll try to register to 10.1.2.3, etc. Okay, how is QoS done after get encryption? Is the DSCP value still visible to the PE routers? Yes, it is. Again, because it's doing that header preservation and copying over the type of service field, that's where the DSCP values live. It is possible for the provider routers to still see those markings. And that's a part of GET. You can't turn it off. So if that's a problem, then them knowing what your DSCP values are, then you would want to use some other method such as DMVPN to encrypt. It might not be a problem though, because you might still want your voice traffic to be prioritized by your MPLS provider, and GET would allow you to do that. Again, because the DSCP values, say your voice is set to EF, they wouldn't be able to see the actual voice traffic, but they would certainly be able to prioritize it based on that value. Okay. Any other questions? Again, I know we didn't show some of the quote-unquote advanced stuff, like co-op key servers and multicast and RSA SIG for authentication. Again, in just a second, I'll show you a link for the forum that I moderate. You can ask the question there, or send it to my email. Real quick here, I just want to say. I think Jerry is going to tell you about this information. Let me unmute him. If I can find him here in the list. There he is. Okay, Jerry, you there?
Yes, I'm here. Can you hear me?
I can, yes.
Perfect. Okay. For those of you who were only able to capture a part of this webinar or not able to capture any of it whatsoever, you can go to lms.ccbootcamp.com starting tomorrow, and we should have the webinar recording available for you. You can also email me. My email address is jerry@ccbootcamp.com, and I'll be more than happy to send you the link as well. More than likely starting tomorrow. It takes about 24 hours to get it together. Steve did mention if you have any advanced level questions that weren't covered in this webinar, we do have a discussion forum. It's securityie.com. There it is under forum. Feel free to post your questions there. It is moderated by our security instructors, including Steve Means, Tim Rowley, Tim Strake, Brad Ellis, and several others. If you need to get a hold of your rep, feel free to give us a call. It's toll-free 877-654-2243. I want to go over a couple specials that we have coming up. For those of you who didn't receive the August or September newsletters and are looking into your lab preparation, the Security Advanced Lab Bootcamp is only $1,995, and that's good until September 30th. And you can add the Mock Lab Bootcamp for only $500 more before close of business tomorrow, August 31st, or you can add it for only $1,000 more before September 30th. Those of you who are busy working on our racks using the 8-hour sessions and need additional time, we are offering CCIE security rack sessions, buy one, get one free. So it's $15 per 8-hour session. You only have until tomorrow, and you can't do it online in the online ordering system because they'll charge you the retail rate. Please get a hold of your rep, or feel free to call me directly or send me an email. I'd be more than happy to help you out. I will be in the office until 8 p.m. Eastern Daylight Time tomorrow for last-minute orders. Lastly, those of you who are looking for a job or looking to post a job to find network engineers, we have a website. It's ccie.jobs. Please feel free to take a look at it. Free for people looking for jobs, a moderate fee for those looking to post jobs. Okay, thank you very much. Thanks, Steve.
All right, thanks, Jerry. Hey, we didn't even have too many people, or only one person drop during the sales part. That's good because I still have some stuff to say. I just wanted to let you guys know. Again, Jerry mentioned securityie.com. It's a real good forum, very active. Not just our instructors, but also there's a decent amount of people that are prepping for their labs currently that I would consider real experts and that can answer a lot of questions. They often do answer questions before I get to them, which is great because it saves me work. I had one other thing I want to say. Oh, about the lab. Don't want this to turn into a big CCIE lab discussion, but hopefully you guys know the open-ended questions have been removed. Also, there's a lab refresh coming up at some point. Cisco hasn't announced it yet, but I would say the lab is very mature right now. We pretty much know what's on it as much as you possibly can. They do change the tests. But like I said, the test is very mature and developed right now, and we've kind of got a lot of the tricks known. So that class that Jerry mentioned, the advanced lab and the mock lab, that's probably worth its weight in gold if you're prepping for your CCIE lab. So that's as salesy as I get. That's the end of the presentation. Once again, I want to thank everybody for their time. Hopefully you got something out of it. And again, if you want to get more advanced, that Security IE forum is the place to go. So thanks a lot, everybody. I'm going to drop off now and stop recording. If you missed anything, it's going to be on that lms.ccbootcamp.com by tomorrow.